Finding extreme values. If a function has a local max or a local min at an interior point of C of its domain and f prime of x exists at C, then f prime of C equals 0. What I mean by that is if the derivative equals 0, it's a local min or a local max. Let's think about that just logically. We know that if the derivative equals 0, then the function has a horizontal tangent. That means that the derivative went from increasing to decreasing or decreasing to increasing. So that means at that point, there must be a max or a min. Let's look at the graph of x to the power of 2/3 on a restricted interval. So on this interval, we have two endpoints, and we have the derivative shown, or the slope of the derivative shown. So as I move the derivative, you see at the point where the derivative does not exist or it equals 0, there is a minimum. Right here at 0, it goes from decreasing to increasing. And then at the two endpoints, we will look at those as well for absolute maxes or absolute mins. So the definition of a critical point. A point in the interior of the domain of f at which f prime of x equals 0 or f prime of x does not exist is called a critical point. These are points we're going to check for maxes or mins. The reason we need to check where it's not defined is because there could be a cusp or a corner which would also work as a max or min. If a function has a local extreme value on an open interval, then the extreme value occurs at that critical point. That just means that local extreme values on an open interval are also critical points. The reason I differentiate and say open interval is because the only difference there is we're not going to include the endpoints. So let's look at a real example and figure out how to find maximum and minimums using the derivative. So we want to find the absolute maximum and minimum values of f of x equals x to the 2/3 on the interval -2 to 3. So first let's just look at the graph. Here's the graph, and you can see that the minimum point is right here at 0, and the maximum is over here at C, which is 3, 2.8, because this other end value is only 1.59. So we know that this is going to be our maximum and this is going to be our minimum, but let me show you how to do it with calculus. So step 1, we need to determine critical points. So what we do is we take our function f of x equals x to the 2/3 and we take the derivative. So you get f prime of x is equal to 2/3 times x to the -1/3, which can also be written as 2 divided by 3 times the cube root of x. So what we do is we set that equal to 0. However, this can never equal 0. So since f of prime of x is never equal to 0, but it does not exist at x equals 0, we can say that our critical points is we have one at x equals 0. If we were able to set this equal to 0 and solve, those would also be our critical points. So step 2 is to evaluate f of x at the critical points and the endpoints. So we're going to evaluate f of x at the critical points and this is very important, the endpoints. This is where a lot of people make a mistake because they forget to evaluate the endpoints. So let's evaluate our critical point. So it's at x equals 0. So f of 0 is 0 to the 2/3, which is just 0. So we get the ordered pair 0, 0. Now for the endpoints. We have our endpoints, which are x equals -2 and x equals 3. So at x equals -2, we get -2 to the 2/3, which is equal to the cube root of -2 squared, which is equal to the cube root of 4, which is about 1.587. Then f of 3 is equal to 3 to the 2/3, which is the cube root of 9, which is about 2.08. So now what we're going to make was what we call a sign chart. This is going to tell me if my points are a maximum and a minimum. Now we know that 0 is a critical point, so we know it's either a max or a min, and by looking at the graph we know it's a min, but we're going to determine using this chart if it's a max or min. Now I want to point out that this chart is not in any way an answer. So on an AP test, this does not count as work. It is a tool, but it does not count as work. So if you were to say to refer to the sign chart, the AP test would not allow that. Okay? So what you do is you write your two endpoints, and then you write the critical points. So we have to pick values in between. So I'm going to pick -1 and 1. And then what you do is you evaluate the derivative at those points. So f prime of -1 is 2 divided by 3 times the cube root of -1, which is -2/3. So all we need to write is this is negative. Then f prime of 1 is 2 divided by 3 times the cube root of 1, which is 2/3. So this is positive. So we know that the graph went down and then pointed back up, which makes this point right here a minimum. Now let's just evaluate all these points with f of x, and this was 1.587, 0, and 2.08. So therefore, this is a min, and this is a max. So this is how I write our answer. Therefore, then f of x is equal to x to the 2/3 has a max, and we can say absolute max of the cube root of 9, which is about 2.08 at x equals 3, and an absolute min of 0 at x equals 0. Now I want to keep in mind that (1.587) at x equals -2 and 2.08 at x equals 3 are also local maxes, and 0 at x equals 0 is a local min. So notice that an absolute max is also a local max, but the local maxes are not necessarily absolute maxes. Okay, so now what I want you to do is I want you to try f of x equals x to the 4/7 on the interval -1 to 2, and I want you to determine the max and min values, both absolute and local. So go ahead right now, take a minute, and try this out. Okay, so now that you've tried it out, let's see what we get. So we have that f of x is equal to x to the 4/7. So f prime of x is equal to 4/7 x to the negative 3/7, which I'm going to write as 4 divided by 7 to the 7th root of x cubed. So first, let's recognize that we don't have any zeros. So f of x has no zeros. But f of x does not exist at x equals 0. So one of our critical points then would be 0. So now what we need to do is we need to evaluate those. What I like to do first is I like to make the sign chart that tells me exactly what I need to do. So I have f prime of x. I have my first endpoint, which is -1. I have my critical point, which is 0. And then my endpoint, which is 2. Any other critical points I would fill in the chart. So for the point in between, I'm going to choose -0.5, and here I'll choose 1. So basically we need to evaluate it at these 5 points. So f of -1 is equal to -1 to the 4/7, which is equal to 1. So I'm going to put a 1 right here. F of 0 is equal to 0 to the 4/7, which is 0. And f of 2 is equal to 2 to the 4/7, which is about 1.49. I just plugged that in the calculator. So right away we can see that we have a absolute max at 2, which is 1.49, because it's bigger than f of -1. And it looks like we have an absolute min of 0 at 0. But to complete the sign chart, we need to find f prime of -0.5. So this is going to be 4 divided by 7 to the 7th root of -0.5 to the 4th. So the way you do this, if you plug it in your calculator, mine at least didn't spit anything out, so I need to do a little simplifying by hand first. Keep in mind that if it's an odd power, we can pull a negative out. So this is equal to -4/7, the 7th power of 0.5 to the 4th. And this you just plug into a calculator and you get -0.769. So right here it's negative. Really, we didn't even need to evaluate it. We just need to look at that negative right there. And then f prime of 1, which is 4 divided by 7, the 7th root of 1 to the 4th, which is 4/7. So it's positive. So we know that this thing is going to go down and then back up. So now we just got to write our conclusion. And we have an absolute max of 1.49 at x equals 2. An absolute min of 0 at x equals 0. We have our local maxes, 1.49 at x equals 2, 1 at x equals -1, and our local mins of 0 at x equals 0. This really is what I'm looking for, and so on your quiz or test, I might ask you for absolute max, local mins, and those kind of things.